Hello everybody, welcome to Science, Technology and History Explained. Today the topic is food, something we all love, but what about the climate impact of food and agriculture? So let's take a look. So starting at looking at greenhouse gas emissions in the world by sector, we see that agriculture is a substantial amount of generates a substantial amount of greenhouse gas emissions. It's 6.2 billion tons of greenhouse gas emissions, and this accounts for around 12% of the world's emissions. We looked at transport when we were talking about electric cars, for example, but a significant part, not as large as transportation sector, but still a substantial part of the greenhouse emissions. Let's take a step back and talk about the basics of food chain and the ecosystem. And of course, for life on Earth, of utmost importance is the plant's ability to do photosynthesis. So plants can have the ability to take the energy of the sun emitted as light. They can capture CO2 from the atmosphere, water, and other important minerals and nutrients from the soil, and produce the sugars and all other elements that make the plant, and this becomes the food for the next steps of the food chain. So, for example, herbivores that consume the plants directly and they become, let's say, meat. But we have to think that the energy efficiency in the food chain is around 10% per step. So from the sun's, let's say, really a lot of energy, the plants only capture a portion of that, but then the herbivore maybe captures 10% of the energy that it consumed from the plant. And then when we add, let's say, the next step of the food chain, let's take a carnivore here. It's even lower efficiency here overall. And this is normally in nature. Carnivores in the top of the food chain are very few, let's say, compared to the herbivores and the plants, and we have a sustainable ecosystem. But what can we do now on Earth when the top of the food chain is 8 billion human people? So, as humans, in order to sustain such a large population, we have been building an industrial food chain. So, 8 billion people that averaging consume, let's say, 35 tons of food in their lifetime. This means that, for example, right now there are around 27 billion chicken. The chicken's average lifespan is 50 days. 202 million are slaughtered daily to become food for people. And then to do all this, we need, for example, 2.4 billion metric tons of grain produced annually. This goes, for example, directly to feed people, but also to, for example, feed the chickens that become meat for people, and of course a multitude of other food sources and food stuff. But again, a very high amount of a very industrial food chain. So if we look at the world population, how are we able to produce so much food? If we look, for example, world population from 1960 up until our days, the world population has grown 2.5 times since the 1960, from 3 billion to 8 billion. So how have we been able to give 2.5 times more food? Can we use more land for agriculture to produce more food? If we look at the same period from the 1960 to the, let's say, to early 2020s, the green here is the global land use for agriculture. This has increased only 10% in the same period, where we saw the global population increasing 2.5 times. But the orange line in this graph, again from our world in data, has quadrupled in the same period. So this means that a person now has even more food per person than in the 1960s, where there only were 3 billion people. So how is that even possible? Let's look at, this is the amount of fertilizer used per per cropland. This is the same scale from 1960 to 2023, and we can see in this period we have seen a six-fold increase in the use of fertilizer. This is the way that with this, let's say basically the same amount of land, we can produce 4 times as much foodstuff, so we can sustain a larger population. And this is an example for corn, for example, corn yield. If we don't have any nitrogen application from the fertilizer, we get this type of, let's say, of yields. But when we use more and more fertilizer, we can get a 3-4-fold increase of the yield of land. And fertilizer is really important if we look at the chemical industry. If we look at the world's top 3 most produced chemicals, this is million metric tons per year. The blue are chemicals here. So we have sulfuric acid, 350 million metric tons per year, ammonia, 250 million metric tons per year, and ethylene, 220. And these are huge amounts of chemicals produced here, but if we put it into some relation, so crude oil is around 4,000 million metric tons per year. So crude oil, let's say the biggest liquid chemical on the planet. This is in another axis, otherwise it wouldn't make sense to show you. But just to show you that from the top 3 most produced chemicals in the chemical industry, sulfuric acid, the main use of that is to produce phosphates for fertilizer to add so we can get higher yield of crops. Phosphates, typically phosphor comes from sediments that rock and so on, and then sulfuric acid is used to leach these rocks so we can make some easy accessible phosphorus that we can spray out and put in the fields for the plants to use. And ammonia, the second largest used chemical in the world, the main use for ammonia is as a nitrogen source for fertilizer. Ammonia is produced from natural gas, so of course there will be some greenhouse gas emissions to produce the ammonia that comes as a fertilizer for the food that we eat. And ethylene is used in plastics mainly, but just to show you that also a big amount of industrial chemicals are used to produce the food that we eat. And then if we look at CO2 intensity of various food types, this is some analysis from our world in data, and here we can see per kilogram of a certain food type how much CO2 equivalents are emitted. And here we can see typically if we have plant-based foods like rice, peas, tomatoes, bananas, and things like that, they have a quite low CO2 footprint per kilogram of the foodstuff. But if we move up to meat, as we saw also in the food chain, herbivores are only, let's say, taking 10% of the energy of the plants. So you need quite a lot of foodstuff to produce, let's say, one kilo of meat, for example, pig meat. Beef and lamb have a very high CO2 amount because the way their digestion system works is they are ruminating, so they are producing methane bacteria that from the food they eat, and this adds a very big amount of CO2. And if we see, so meat types produce much more CO2 than plant-based types. And we can see, for example, for something like if we look at, for example, beef from beef herd, this is one of the highest amounts of CO2 or greenhouse gas emissions per kilo of the food. We can see, for example, transportation and processing and retail and things like that is almost negligible compared to the other parts of land use and the farming and the feed that they need to eat. So eating, if you want to, let's say, reduce your CO2 amount, then eating a plant-based is much better than just eating locally. So if you eat, for example, pig meat from close, or if you eat peas from abroad, the peas from abroad are very much lower CO2 content. And then somebody might argue, but okay, 1 kilogram of meat maybe has more nutrition than 1 kilogram of potatoes or something like this. But this is, for example, if we look at the greenhouse gas emissions, now instead of per kilos, we look at calories or even protein. The big picture is the same. Plant-based foodstuffs are much more efficient to produce with less greenhouse gas emissions for the food, for the nutrition we are getting as humans. So overall, what can we do to reduce the greenhouse gas emissions from agriculture and food? I think the most impactful way is to eat more plant-based food and less meat. You can also, plants also have high protein, and especially beef and lamb that are producing a lot of methane are the worst culprits for greenhouse gas emissions. So maybe I will not be advocating that everybody should stop eating meat. I'm not a vegetarian myself, but I think we all could eat a little bit less meat and still have a nice varied and healthy diet. Of course, also reducing food waste. If we are producing a lot of food that ends up being just thrown away, it's of course a waste of energy and greenhouse gases. Then another thing is to use green fertilizers. For example, if we have a lot of renewable electricity, then we could do electrolysis of water. That gives us hydrogen. We can take the nitrogen from the air and produce green ammonia that is not fossil based from natural gas, and then we can make the nitrogen source for our crops to get high yields. And then it could also be something like electrification of agriculture machinery. All the machinery that is used on the farms and agriculture, they could maybe be electrified. And of course, to do something like green fertilizers or electrifying the agriculture machinery, we need a greener electricity grid and non-fossil types of electricity. So this concludes this video of this quite complex topic of food sustenance and greenhouse emissions and what we should put on our plate. And let me know your comments and thoughts after seeing this data. When analyzing all this data, it's a bit staggering, the amounts of, for example, how many chickens are there in the world and how many animals are slaughtered every day, and how can we feed the population in a sustainable way going forward. So let me know your comments and thoughts, and please press like and subscribe to my channel, where I will be bringing you other topics for science, technology, history, and climate change and sustainable future. So this is we are signing out. Stay safe out there, and bye bye.